Hello everybody, welcome back to my channel. My name is Michael. I hope you're having a wonderful day so far. Today marks week 6 of Harvard CS50X 2025, which is the week on Python. This is a condensed recording of my live stream I did where I watched this lecture live alongside chat. Please see the description below for a link to that live stream. Thanks so much for joining me here, and let's get started.
And we'll skate our way toward some snacks in just a few. All right, so let me propose that we look at one other problem from our week 4, wherein memory and the fact that it exists and has to be managed by us was creating some underlying problem. So let me open up a program from week 4 that was called copy5.c. At least that was our several iterations in. And that program looked a little something like this. And I'll just skim it for a second. Like, this was getting kind of annoying just to copy one string into another. So I had to use all of these libraries in C. I used CS50's getString function still, but this is when we took the training wheels of strings off, quote unquote, and started talking about them as char stars. I checked to make sure that S is not null, just in case we're out of memory for some reason. I used malloc ultimately to create more memory, to get more memory for the copy, but still checking if it's null. I then copied the string from one to the other using stir copy. I then made sure the string was long enough, and then I uppercased the first letter in it. Then I printed them out. Then I freed the string, and so forth. Like, it was a lot of work just to make a copy of a string, which in programming in general, it'd be nice if you could just do it more simply. So in Python, here too, it's as simple as that. Let me go into VS Code, open up a new file called copy.py. Then let me put these two side by side. And in the right-hand version in Python, let's do this. S equals input, and prompt the user as before for a string like S, quote unquote. Then let's go ahead and create a second variable called t, set it equal to the S variables, capitalize method's return value, and then print out down here, how about S, and then print out t. Let me open my terminal. Let me run Python of copy.py. Recall that last time when I did HI exclamation point, it capitalized the whole thing, as I recall, as opposed to capitalizing just the first letter. Enter. This time, it works as expected. Now, the print is technically a little different. Down here, I use these format strings. So if I really want to make this identical, I can do F, quote unquote, S, colon, and then plug in the value of S with curly braces. F, quote unquote, T, colon, T. This looks uglier, but it's just now printing out prefixes here, S and T respectively. So if I run this again and do hi in all lowercase, it capitalizes it correctly for T and only for T. So here, more so than ever, 33 lines of code at the left, 6 lines, 2 of which are blank at right in Python. Oh, all right, how about this? Let me propose that in C, we also at one point tried to just uppercase everything in a string. So let me open up what was a program called, from week 2, uppercase .c, or really version 2 thereof here. And this was a program that looks a little cryptic, but all it does was ask the user for a string, the before version. It then printed out after colon as just a placeholder for an uppercase version thereof. We then use strlang and this for loop to iterate over all of the characters in the string. And then one at a time, we use the C-type libraries to upper function to capitalize them again and again. So you can probably imagine where this is going. We don't need to upper anymore. We can just use dot upper in some way. But we do need to have the ability to do things with loops. So in Python, we still have loops, but the syntax is going to be a little different and frankly a little easier ultimately. So in Scratch, if you wanted to repeat something 3 times like this, you could implement it in C very mechanically, so to speak, like this. Create a variable I, increment it with ++ again and again and again, so long as it's less than 3, printing meow each time. In Python, you can do the exact same thing if you really want by saying variable equals value, but no semicolon, no data type, while I less than 3 colon. So just like conditionals, you don't need parentheses if they're not logically necessary, but you do need the colon and you do need indentation. You don't have the ++, so we have to do the slightly more verbose Python version here. But that's exactly the same idea to implement meowing 3 times. Suppose, though, that we wanted to take a different approach here. We could, in C, use not a while loop, but a for loop. And maybe you're nowadays in the habit of using these a bit more. They're a little more succinct without all of the vertical clutter. But this is how we could implement the same in C. In Python, it's not quite as obvious how to do this, but we could do it this way. we could say for I in the following list of values. And literally in square brackets, as I did earlier, just enumerate one after the other the things I want to check for. Instead of y and yes and no and n, I can iterate over 3 values. This is fine, but just allow your mind to kind of wander, if it hasn't already, into thinking how this could get us in trouble. Like, why is this approach of just enumerating 0, 1, and 2 probably not the best way long term to do this?
You might run out of indexes.
Yeah. Yeah, are you really going to go, what if you need a lot of values, like 100 of them? Are you really going to do 0, 1, 2, 3, dot, 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 2, 99? Like, that's got to be a better, there's got to be a better way than that. If only because it's going to wrap around the screen, I'm going to miscount and screw something up. So indeed there is. You can alternatively use a function in Python called range, which does, as I said earlier, give you a range of values. And if you want a range of 3 values, starting at 0 by default and going up 2, but not through this value, you literally call the range function and say, how many values do you want? And essentially what the range function does is it hands you out 1 value at a time more efficiently than the hard-coded list, which puts them all in memory at once. Range is a little smarter, and it knows how to give you indeed just 1 value at a time. But notice here, I'm using for I in range of 3, which is similar in spirit to C, because I have this variable I. But I'm not actually using I anywhere. Like, I'm not incrementing it. I'm not comparing it against a value. So strictly speaking in Python, this is correct. But stylistically, some people would actually, by convention, change the I to just an underscore character, which is a valid character for a variable. But it's just kind of this visual indicator that, yes, this is a variable because the for loop requires it in Python. But who cares what it's called, because I'm never actually going to use it. So you'll see this convention sometimes, but perfectly reasonable to also use I by convention, because I means integer, and that's really what's happening anyway. But just FYI, a convention there in Python. So how can we now use these loops in some actual code? Well, let me propose that what we could do here is the following. Let me go back to VS Code here in my uppercase version. And let me quickly whip up a Python version that achieves something quite similar. Let me go ahead and run code of uppercase.py. At top left, after dragging this over, let's go ahead and implement the following. A variable called before, set it equal to the return value of the input function with quote unquote before as the prompt. Then let's just do a placeholder of quote unquote after colon space space, so they lined up in terms of numbers of letters, close quote, comma. But let me do end equals quote unquote, because I don't want a new line to move the word below the word after. So this is just a silly aesthetic detail. But that overrides the default new line to being no new line. Now let's do this. In Python, instead of using this convoluted for loop and the semicolons therein and this constant checking of a conditional, I can actually just do this. For every character, call it C, in the before string, go ahead and print out that character uppercased like that, but don't print out a new line yet. Until we get to the very end, go ahead and print a new line by printing nothing. But by default, I'm going to get a new line. So passing nothing in gives me 1 new line.
Why is he putting in uppercase?
So let me open let me open my terminal.
Run
Python of uppercase.py, hi exclamation point in lowercase, enter. And I've messed.
I know it right. He's going to have an error. Why is he using uppercase? It's not upper. Come on, man.
Notice the error here. So this is, I can make this work. So there's these things in Python called tracebacks, which kind of trace backwards what you did wrong. And in this case, what I did wrong, as per all of these caret symbols, is C.uppercase is bad. But you probably already know that from earlier. What should have typed? So .upper. So there's a lot of distraction here, but much like Clang's output, there is some helpful information. 1, the file in question is uppercase.py. Line 4 is where I made the mistake. So even though the output is different from Clang's, it is similar in spirit. Specifically, I messed up an attribute error because some string object doesn't have an attribute that is a method called uppercase. All right, well, that's an easy fix, as you noted. I should have written C.upper, delete, delete, delete. And now, let's clear my screen, rerun Python of uppercase.py, enter, hi exclamation point, and there we have the after version thereof. But even here, note that in Python, I'm doing even more work than I need to. This is indeed how in Python I can enumerate all of the I can iterate over all of the characters in a string. Like there's no i's, there's no conditionals. Python will just, on every iteration, update the variable C to contain one letter, then the next, then the next, then the next. It just sort of works the way you would hope. But in Python 2, recall that you don't have individual characters anyway. So technically, I'm kind of wasting my time by doing this one string of size 1 at a time, again and again and again. I can tighten all of this up here. And I can just, for instance, do this. I can go ahead and print out, for instance, before.upper. And just uppercase the whole thing all at once. And then I could technically get rid of the new line. But now I'm just wasting my time, too. Let me get rid of all of this. Let me go over here. And let me output, for instance, let me create a variable called after equals before dot upper. That's going to store in the after variable exactly what I want all at once without even using a for loop. And now I can print out as before a an f string saying after colon space space and then the value of the after variable. So this, if I run it again, Python of uppercase dot py, enter, pi in all lowercase, enter. That too now works. And one final flourish, strictly speaking, you can interpolate the value of what's returned from a function as follows. Instead of even bothering with a variable here, I put a modest amount of code inside of the curly braces. And I say modest because if this gets too long, it's just going to confuse everyone, yourself included. But in this case here, I can run this one more time, type in hi in all lowercase, and that too now works because I'm formatting it as an f string. So in short, I'm just getting more and more features at my disposal that I can now use to solve some of these same problems. So that there was a lot. Let's go ahead and take a 10-minute break with some fruit by the foot, and we'll be back with more complicated problems. So let's go and use some of this new syntax to actually make a meowing cat, albeit textually in Python. So back here in VS Code, I'm going to go ahead and create a program called meow.py. And let's first do it the super simple way. If we want the cat to meow 3 times, let's literally just do that in code. So print, quote unquote, meow, and we get the new line for free. And then I'm just going to copy paste this again and again. It's just going to give me 3 such lines. Python of meow.py, enter, and there we have it. A cat that meows 3 times. Of course, this is correct but not well designed, because what should I obviously be using instead as a feature of any language?
Variables.
Instead of 3 copy-pasted statements?
Variables.
Probably like a loop of some sort. So let's borrow some of the inspiration from those previous slides. Let's go into meow.py and change this to use maybe a while loop initially. So how about I equals 0, then while I is less than 3, go ahead and print out meow. And then let's go ahead and do I plus equals 1, which is the relatively quick way to do that in Python, but not like C's++. Python of meow.py, enter. OK, so correct and better designed now. How else could I do that? Well, we saw earlier that I could do for I in 0, 1, 2, colon, and then I can do print, quote unquote, meow. That too would work. If I rerun Python of meow.py, that works. But notice I'm not using I, and indeed I'm not using 0 or 1 and 2. So technically I could do something like quote unquote cat, dog, bird. I just need 3 things to enumerate over, and that too is going to give me 3 meows. So to be clear, the square brackets, much like in C, are giving me a list of values, but it's not an array. It's indeed a Python list. And as we'll see over time, a list in Python is nice versus an array in C because lists in Python can grow and shrink automatically for you. So not only are they linked lists of some sort underneath the hood, you do not need to worry about resizing them anymore. But of course, as we saw before the break, we should probably just do this more dynamically. So for I in the range of 3 values, and let Python generate those for me. If I rerun Python of meow.py, I still get 3 values. But here too, stylistically recall, we said that you don't really need the name of the variable if you're just going to do something 3 times without ever touching that value. So we could just use an underscore by convention, which just kind of looks like there's no variable there, even though there in fact is. But let's build on this and actually now introduce and really revisit the ability to define our own functions, which we've seen in Scratch, we've seen in C, and I technically at the start of class used it to implement my own spell checker. In dictionary.py, I used def, which stands for define, and that's how I defined 4 functions identically named to problem set 5s. Well, let me go ahead and do this and implement an abstraction for meowing, much like we did in Scratch, much like we did in C. Let me go ahead and define a function called meow, whose purpose in life is simply for now to print out quote unquote meow. And now let me use that. Let me go ahead and do something like before. So for I in range of 3, go ahead and call meow like this. I think that's going to get the job done. Python of meow.py, enter, and indeed, it's still working exactly as I expected. But recall from our discussion of C, we generally stylistically encouraged you to put your main code at the top of the file, if only because that's the entry point to the program. If you want to wrap your mind around the code in there, it makes sense to start with main instead of random functions like meow at the top of the file. So let me actually kind of practice what we preached in C. Let me move this meow function just to the bottom of my file so that it's sort of out of sight, out of mind, because now that it's implemented, it just exists. Let me go back to VS Code, my terminal in VS Code, run Python of meow again, and hit enter. And there's one of those tracebacks, a different one this time. This time it's a name error instead of an attribute error. But where did I go wrong? Apparently, MEOW no longer exists by nature of having moved it from top to bottom. So intuitively, even if you're new to Python, why might that be?
Outside of its scope.
Yeah, exactly. I need to define it before I call it. Very similar to C, whereby at least in C, we had that little trick of just copy-pasting the prototype of the function, just to borrowing its very first line. Python actually doesn't use that mechanism. Instead, Python has a different convention instead. Technically in Python, you do not need a main function. Clearly, from all of the programs I've written, it just works without a main function. But if you get yourself into a situation where you're defining your own functions, but the order in which you define them and then use them clearly matters, you might as well go ahead and implement a main function after all. And the convention would be to do this. Literally define with the def keyword a function called main that doesn't need to take any arguments. And then inside of that main function, put your actual code. Indentation in Python matters. And so I've hit tab to indent everything all at once. And now I have a main function. So it would seem that maybe now the problem is solved by just introducing main. So Python of meow.py, enter. OK, it's solved in the sense that I'm not seeing an error message anymore. But explain to me intuitively why I'm not seeing anything at all. Yeah? I didn't call main. So it's sort of like we're taking a step forward, but then another step backwards here in the sense that Python doesn't come with a main function, support for a main function by default. So if you invent it yourself, the onus is on you to call that function. So this is going to look a little stupid, but the convention in Python is indeed at the very bottom of your program, if it's contained in a single file, is literally call main at the very bottom. So now I'm going to go back to VS Code. I'm going to rerun meow.py, and now I get back the functionality. But I don't get an error message either. Why? Well, in this case, on line 1, I'm defining the main function as follows. On line 6, I'm defining the meow function as follows. I am not using either of those functions in actuality until line 10 calls main, which then calls meow. So I fixed my sort of order of operations. So it's fine for main to be defined above it, so long as I don't actually call meow until I've defined it as well. So this defines main, defines meow, and then actually calls main. So this is a nice way in Python to sort of avoid what could be a very complicated design problem by just defining our own functions, including one called main. Strictly speaking, it doesn't even have to be called main, but it would be frowned upon as a matter of design, as a matter of style, to call it anything other than main, even though that has no special meaning beyond convention. Well, let's make one tweak here. Just as in C, just as in Scratch, it would be nice if meow actually took an argument, which is the number of times I want to meow. So let's assume that that functionality exists by calling meow of 3. As the input to that function. But how do I now change the definition of meow? Well, just like in C, you put inside of the parentheses when defining the function a comma-separated list of 0 or more parameters. And I can call it anything I want. I'll call it n for number of times. I don't have to specify int, though, because we know that already. But in now this loop, I can do for I in range of n. It doesn't have to be 3. It can be n as a variable's value. Then indent this line so that it indeed iterates n times, printing out meow in this case. If I run it again as Python of meow.py, enter, now I see meow, meow, meow. But this is arguably the best designed of my versions thus far, because it is indeed parameterizing how many times I'm meowing. Now, as an aside, especially those of you who might have used Python before or might go on and look at tutorials and such for Python itself as a language, technically the conventional way to call main is with this weird syntax. If underscore name underscore equals quote, quote, underscore main underscore quote, colon tab. We don't
Oh,
bother doing this in
main,
most
not
of our
main.
class
Shoot,
examples
I
because
got
it
it
doesn't
right.
actually solve a problem that we ourselves will encounter, and it's just really hard to remember and confusing to read. But you will see this in the wild, in the real world. And long story short, this syntax of line 10 being added solves problems where you're implementing not your own program per se, but your own library. Where your own library that may very well have its own main function. But for now, I'm going to wave my hand and make that go away and keep it simple, because this is the juicy idea for now. As an aside, there's other ways to have loops in Python that's worth noting. So for instance, in Scratch, we had this forever block saying meow again and again and again without ever stopping. In C, maybe one way to do this was like this, like while true, because true is always true. So this conditional is always true, so it's just going to print endlessly. In Python, the syntax is roughly the same, while true, but capital T and capital F for false. This too would achieve the same result. And so just to demonstrate, though, a very common mistake might be to have some kind of infinite loop in your code. That might happen just the same in Python. So if I go back to meow.py, and just for kicks, I simplify this to literally just while capital true colon print quote unquote meow, you could get yourself into some trouble here by running that code. And it just seems to meow endlessly. How do I get out of this situation?
Control
Besides,
C.
like reloading my browser and closing the terminal. What's this more elegant way? Yeah, Control C. So Control C for interrupt will cancel what's going on there, just like in C. This, though, does not mean there's an error in your code. C did not do this. Python does show a keyboard interrupt error, if you will, but that's because you literally interrupted the program while it was running. This doesn't mean there's a problem in your code if you've simply interrupted it because you lost control over the thing. All right, so what are some other issues we can perhaps now revisit together? So in the world of C, recall that we ran into issues of truncation, whereby if we did integer math, it's like 1 divided by 3, that would give me, ideally in the real world, 0.33333 forever. But it ended up coming out as 0 in C as well. So let's see what happens in the world of Python now. And I'm going to move away from showing left and right C in Python. For now, let's go ahead and just focus on the Python code. So let's try this. Let me go and create a new program after closing meow.py called, say, calculator.py again. Let me throw away the relatively simple code earlier that simply added two numbers together. And let's do some division now. So let's do x equals int, passing in the input, asking for an x value like this. Let's do y equals int input, passing in a y prompt like that. Then let's do a variable called z equals x divided by y. And then let's print out z. So this is actually very similar to something we did weeks ago in C when we first tripped over this issue. Let me run Python of calculator.py, type in 1 for x, 3 for y. And it would seem as though truncation is not an issue in Python by simply using the slash symbol for division. Turns out there's another symbol you can use in Python if you want to get back truncation. You can do slash slash, which is not a comment. It actually means do division like the way C used to do it. But in Python, probably for the benefit of all of us globally, division works as you would expect. And you get back, in fact, this here value instead. What about another issue we saw in C, that of floating point imprecision, whereby even though something's supposed to be 0.3333333 infinitely many times, it seemed like, remember, like grade school was lying to us because there were weird numbers in even a fraction like 1/3. Well, let's try this out in Python. Let's go back to my here calculator, and I only need to make a slight tweak here, for instance, though the syntax is going to be a little weird here. Instead of just printing out z to some default number of significant digits, let's actually format the string as follows. And this is not syntax you'll need frequently, but in Python, you can use an f string by doing f quote unquote something. And inside of the double quotes this time, instead of just doing z to print out and interpolate the value of z inside of those curly braces, let's specify that, yes, I want the value of z, but I want to print it to like 50 decimal places as a floating point value. I have to Google this syntax all the time to remember what it is, but this is saying exactly that. Show me 50 significant digits in this here number. So let's go back to my terminal, Python of calculator.py, enter 1, 3, should get 0.33 repeating forever. But of course we do not. So unfortunately, Python does not solve all of our problems. Floating point imprecision is still an issue. Does that mean you shouldn't use it for scientific computing, for financial computing, and the like? No. There are libraries that you can use, third-party code, that sort of addresses this kind of concern. But you still need to be mindful of the fact that these problems still exist, and either you or someone else still needs to handle something like this. What about something like integer overflow? Well, wonderfully in Python, integer overflow is not a thing. Recall that in Python, in C, if you use an int of 32 bits, it's eventually going to overflow and go negative or go back to 0 once you count beyond like 2 billion or 4 billion, depending on if you're doing negatives or not. You could use a long in C, which gave you 64 bits, which means it's still going to overflow, but probably after we're all dead, because the number is going to count up much, much, much higher. Unfortunately, well, fortunately in Python, you don't have to worry about int. You don't have to worry about long. It will just allocate more and more bits for you automatically, secretly underneath the hood. So you can just iterate from 0 on up toward infinity, and the program will run theoretically forever without ever actually overflowing the int. So at least integer overflow, not a problem. But there are problems that might still happen, and let's explore how there are new mechanisms in Python and languages like it that we didn't have in C. So in particular, let's introduce something called exceptions, which is sort of a concept and a feature that's worth understanding so that you'll encounter it not only in Python, but also likely in the real world. And let's do it as follows. Let me go back to VS Code after closing my calculator, and let me go ahead and open up a new program called integer.py just to play around with integers. And let me go ahead and do this. Let me first prompt the user for a number n, set it equal to the return value of input by just asking them, whoops, in between quotes, a prompt of input. Like I really just want them to type a number, but maybe they won't. So let's see what happens. There are ways now to detect if the human has typed in not only a string, but a numeric string, like 1 or 3 or something else. I can simply use a conditional in Python pretty easily. In C, I would have to do this pretty much character by character by character. In Python, I can do it the whole string at once. If n dot is numeric, open paren, close paren, thereby using a method that comes with all strings in Python that will just tell me true or false, this whole thing is numeric or not. Then I can go ahead and print out, for instance, integer, just concluding that this here thing is an integer. Else, if it is not all numeric, I'm going to go ahead and print out not integer, quote unquote. Let's try this out. Let me run Python of integer.py. I'll type in 1. That's an integer. Let's run it again. Type in 3. That's an integer. Let's run it again. Type in cat. That is not an integer. So it seems to work at a glance. But how else might we go about doing this, especially if so that we don't have to litter our code with all of these darn conditionals every time I'm just trying to get an int. I don't want to resort to the CS50 library, ideally. I don't want training wheels. But I want to do this the Python way. And there's a word for that, the Pythonic way. So that, too, is a term of art, which means there might be different ways to do it. But do it the way where a majority of people out there would probably agree with you, Pythonically. All right, so let's do this. Let's just, instead of bothering with the conditional, because this is kind of annoying that one line of code really becomes 4 all of a sudden. Let's just go ahead and proactively convert what the human types in to an int, as I did before to fix the 12 problem. Let's run Python of integer.py, enter. Let's do 1, enter. Seems to not make any errors. Nothing bad happened. Let's type in 3. That there works too. Let's type in cat. And that throws one of those tracebacks, where the traceback itself is not the error, but it's diagnostic information that's trying to help me figure out where I screwed up. Apparently, I screwed up somewhere in this whole thing. And this is a little cryptic, but this is a value error. I screwed up a value here. Invalid literal for int with base 10 cat. So that's a very verbose way of saying, by default, the int function assumes base 10, aka decimal. And it doesn't understand cat. So it's just not working on cat. So how do I solve this? Well, notice what's happening here. Simply trying to convert cat to an integer is not just returning some special value like 0 or -1. Like it's literally terminating my whole program. And this is different from C. Recall that in C, the only way you could signal errors that we've seen is that you have to return a sentinel value like 0 or -1 or +1 or null or whatever. Like you have to know in advance what special value is going to come back. But there's a problem with integers in particular. Suppose that the int function was defined in its documentation as returning 0 if anything goes wrong. You could check for 0. So if n equals 0, then you could say print not integer, because according to the documentation I'm pretending exists, that is an invalid value. Of course, where does this get me into trouble? If I run python of integer.py, type in 1, we're good. Type in 2, we're good. Type in 0, 0 is not an integer, but I'm pretty sure it is. So there's a problem whereby if you're relying on return values to signal that something went wrong, you have to sacrifice a potentially valid value. And that's fine, but you're going to have to pick a number. It's got to return 0, -1, +1, 4 billion, -4 billion. Like, you've got to pick a lane. And that's unfortunate because you're sacrificing some value unnecessarily. So what Python does, and what other languages do, is instead of returning some sentinel value that means something went wrong, they just throw up their hands, so to speak. They throw an exception. And an exception, by default, just terminates the program because something unexpected happened. Something exceptional, or in this case, exceptional is a bad thing. Something exceptional happened. So how can we handle this? How can we actually detect that something has gone wrong? Well, it turns out, this is sort of kind of encouraging, you can try to do something instead in Python as opposed to just blindly doing it. So if I go back into VS Code here and I try to do that, let's do the following. Ideally, I want the end result to look like this. Print integer if this thing works. And so to be clear, let me run this once more. Python of integer.py, 1 is an integer. 2 is an integer. Cat, not an integer, but I'd like to see not integer and not some crazy message on the screen. So how can I fix this? Well, let's do this instead. Please try to do all of this, except if there's a value error, as I know can happen because I just experienced it, then go ahead and print out not integer, quote unquote. So let me just keep my grammar the same. Python of integer.py, enter, 1 works. Python of integer.py, 3 works. Python of integer.py, cat doesn't work per se, but it doesn't throw an error message anymore, and that scary traceback. I'm somehow catching the exception or handling the exception, so to speak. Now, as an aside, the slightly better way to do this would also be as follows. Generally speaking, it's considered a bit lazy and bad design to put more lines of code in a try statement than you strictly need. Because imagine a program has like 30 lines of code. Maybe it's your whole piece set problem, and you know you're occasionally getting those traceback errors on the screen. You know, sort of a bad student, for instance, would just put everything in the try block and like literally just try to do your homework. And if there's an exception, then you just catch it at the very bottom. Like, that's frowned upon because it's just bad design. When you're trying to do something, you should really only wrap the 1 or more lines that will actually raise an exception inside of it. So technically, print is not going to fail. Like, you can't screw up print when you're just printing out quote unquote integer. So weirdly, the try except statement in Python also supports an else, whereby if there's not an exception, you can then do this statement instead. It's a little weird because we've only seen else's and conditionals, but you'll see this in the real world. This, though, would achieve the exact same thing, but it's a little better because now the only line of code I'm wrapping is the one that can actually raise this exception in the first place. So Python of integer.py, 1 works. 3 works. Oh, wait a minute. Oh, wait. That's completely illogical. Does not work. This is supposed to say integer if it is not, in fact, an exception. Sorry, user error. Python of integer.py, 1 works. 3 works. Cat is caught, but therefore not an integer in this case. So long story short, why do we introduce this? Well, one, these exceptions are actually omnipresent in higher level languages, and this is the way that many languages actually raise exceptions, signal that errors has happened, as opposed to reserving arbitrarily some special return value that you must check for. But you need to now try to do certain things, except if errors happen, in which case you can catch them, so to speak, in this way. As an aside, how does CS50's getInt function in our library work? We essentially are using try and except inside of a loop that just keeps prompting and prompting and prompting the user for an actual integer until you oblige, and then we return that value in CS50's Python version of getInt. So we're using the same fundamental in there. All right, let's try now a few familiar things here on stage in homage to the Python crawling on Mario's bricks here. So recall that a few weeks ago, we played around with something super simple like this in C, which wasn't syntactically as simple, but the idea was to print out a column of, for instance, 3 bricks. How might I go about doing this in code? Well, let's see.
Print.
Let me open up a new file
Break.
called mario.py today. And let's just do it the simplest way possible. If I want to print 3
Like that.
bricks, I could do for I in range of 3, and then I could print out a
not
single
the
hash
easiest way
mark to represent
possible.
exactly that. I'm going to get the new line for free because that's the automatic default behavior for print. So if I run this, I get something that's a little underwhelming, but pretty close to the spirit of what I just did here on the screen.
Well, you get the second backslash n, actually.
What if, though, I want to prompt the user for the height of this thing, just as we did in problem set 1 with the Mario problems? How can I make sure the user actually gives me a number I want? Well, let's go back to VS Code here. And just so that I don't have to implement all the try except stuff myself, let's go ahead and from CS50's library, import the getInt function that I've claimed exists. And then let's do this, while true. It turns out, in Python especially, it's actually pretty common to deliberately induce infinite loops, if only because Python does not have do-while loops. Recall that do-while loops in C were super useful because they guarantee that you do something while a condition is still true. And that allowed us to get user input at least once, and maybe again and again and again and again. Python does not have a do-while, but you can implement the idea of it by just saying, start an infinite loop that I'm going to plan to break out of when I am ready. And I could do something like this. N equals getInt, prompting the user for height here as a prompt. Then, if n is what I want it to be, a value greater than 0, as in problem set 1, go ahead and break out of this loop. So even though I don't have a do-while, I can certainly deliberately get myself into an infinite loop and break out of it when I'm logically ready to do so. And now here I can do for I in range of n, which is just going to iterate from 0 on up to that value, and then print out a hash mark as follows. Let me go ahead and run Python of Mario.py, type in a height of 3, and it still works. Type in a height of, say, 5, it too works by iterating 5 times instead of 3. As an aside, what are some modifications that might be germane here? Well, if I want to import the entirety of CS50's library, I can indeed, as I said earlier, just import the library itself. But notice what happens now. Python of Mario.py, enter a traceback, specifically a name error, getInt is not defined. This is because Python actually solves a problem that C does not. In C, we didn't actually encounter this because our programs haven't been too big. But in C, if you include this library and this one and this one and this one, you will get into trouble if 2 people out there have named a function the same thing. If they've typedef something the same thing. There's no notion of scope when it comes to importing libraries in C. You will get name collisions. And the solution is just don't do that. Don't use that library that conflicts with one you're using. Humans realized eventually this is probably not the best design, so they introduced the notion of namespacing, whereby you can scope certain symbols to specific files, in effect. And so there is a solution to this. If you import the entirety of CS50, that's fine, but you have to say that you want the function called getInt that's inside of the CS50 library. So if I do cs50.getInt and rerun this, now I no longer see that error, and I'm on my way again with the code. And this just allows me to keep all of my get_something functions scoped to the CS50 symbol, as opposed to importing them all into like the top level namespace, where they're just essentially global instead.
No questions from me here, boys.
So we had these 4 like coins, question marks in the sky here, different in that they were horizontal instead of vertical. How might we implement this in code instead? Well, let's go back to Mario.py. Let's delete the vertical version we just did. And there's a bunch of ways I can do this, but let's do it in a way that lets us play around with some new features of Python as well. For I in range of, let's say, 4, though I could use a variable if I want, print out quote unquote question mark. And let's try this. Python of Mario.py, enter. This is, of course, buggy because they're coming out vertical instead of horizontal. So what's the fix there intuitively? Yeah, so add end equals quote unquote to turn off the new line by default. That's close now. So if I run Mario.py again, I get 4 horizontally, but I don't get the prompt on the new line. So I think I just need 1 extra print at the end, which does give me a default new line. So if I now run this one more time, there we go. Now we're back in business. So pretty straightforward, pretty much the same as in C, albeit with Python's more succinct syntax. But this is kind of cool. What you could alternatively do in Python, which we've not seen before, if you want to print something 4 times or some number of times,
do it my way here.
You can literally say, print out a question mark 4 times.
Yes,
Concatenation
I
is
knew
now
it.
used
I
in the
knew that
way
was
plus
allowed.
kind of is for concatenation, but this does something again and again. Python of Mario.py, and that too now works. Doesn't really save us a huge amount of time, but it's kind of cool now that you can like do these one-liners, so to speak, that achieve a lot more functionality as well. What about this final example we had from the world of Mario Underground, which was like a 3x3 grid? How could I do this in Python instead? Well, let's go back here and delete the version of code I had there. Just like in C, we can have nested loops. So I could do something like for I in range of 3, and then maybe for j in range of 3, using different variables deliberately here. Let me go ahead and print out a hash mark with no line ending until we're at the end of that row, at which point I do want a line ending, the new line character there. So if I run Python of Mario.py, I get a 3x3 grid, which roughly resembles what this thing here looks like. Now, you don't strictly need all of that because we can combine these ideas for better or for worse. If I go back to my code here, well, if I want to just print out 3 things, I could just do, let's see, print quote unquote hash mark times 3 and allow me to have a new line there. And if I run this version, which is a little tighter, I get the same exact thing too. So where is the line? Like, which way do you do it? Whatever is most comfortable to you. And in fact, when I said earlier that I was doing kind of flexing when I implemented dictionary.py using the fewest lines of code possible, that was just because I really wanted to distill it into the essence of the minimal number of lines of code. But I could absolutely have used some loops in dictionary.py. I could have used a little more verboseness. But as we're seeing here, it's not strictly necessary. Python has even more syntactic sugar, if you will, that lets you achieve more stuff more succinctly. Now, some more on lists and dictionaries just to dovetail with what we did last week. We'll touch on some final features too when it comes to command line arguments and using exit commands. And then we'll end with a couple of fun examples that kind of ties this all together. So in Python, we indeed have lists, which are like arrays, but they dynamically resize themselves. So they're effectively linked lists that you don't need to manage yourself. It turns out the documentation for those are at this URL here, but that's discoverable via docs.python.org itself. In particular, there's functions you can use on list like len, L-E-N for short, which gives you the length of a list. In C, it was up to you to keep track of the length of an array. In Python, like in Java, like in JavaScript, if you're familiar, you can just ask the list how long it is at any moment in time. So that's going to make our lives a little easier as well. In particular, here's some documentation for that length function. And let me take it out for a spin by recreating some of our prior examples in code. Let me go back to VS Code here. And let me go ahead and create a program called scores.py, which just like our example in week 2, sort of iterates over quiz scores or homework scores or however you want to think about scores. In Python, I'm going to give myself just a list of 3 scores, same as in week 2. So scores equals square bracket 72, 73, 33. So this is different from C. In C, if you were initializing an array with values like these, you would actually use curly braces and a semicolon. And the data type in Python, you use square brackets, no data type, no semicolon. OK, as before. Now let's compute like the average of my score. So average equals, and here's another function that actually exists in Python's documentation. You can actually call a function called sum, pass in most anything that you can iterate over, like a list, passing in scores, and then divide by how many of those things there are, like len, passing in scores there. And now if I want to print out the average, I can print out, for instance, a format string that says average colon, and then plugs in that value there. I can try running this, Python of scores.py, and there's my average, as we've seen before weeks ago, 59.33333, with a little bit of imprecision thrown in for good measure, as before. But what's nice is that, notice, sum just comes with the language. Length just comes with the language. You don't need some annoying for loop or a while loop just to figure out the average of these values by doing all of that math yourself. So that seems to be nice at a glance. What else can we do with these here scores? Well, let me propose that we could get them one at a time from the user instead of hard coding them. So let me do this. Let me go ahead and, from CS50's library, import getInt, just so I don't throw any of those exceptions by typing in cat or dog or anything not an integer. Let's give myself an empty list by just using 2 square brackets like that. And now let's go ahead and put things in that list as follows. For I in range of 3, if I want to prompt the user still for 3 scores for the sake of discussion, let's prompt the user for a score, putting it in a variable called score, setting it equal to the getInt function, prompting them for their first score. But then let's put that score in the list. In C, this was a pain in the neck. In C, this was like what you had to do in problem set 5 and build the darn linked list yourself by iterating over the chains and appending it to the end or to the beginning or something like that. In Python, if you want to append a value to an existing list, you do whatever that list is called, scores in this case. You use a method that comes with it called append, and you append that score. And voila, like Python takes care of it for you, putting it at the end of the list. Now, outside of that loop, let me calculate the average just as before, the sum of those scores divided by the length of those scores. Then let's go ahead and print out an f string that says average colon, and then interpolates the value of that variable. Now, if I didn't screw up, let's try this again. Python of scores.py, 72, 73, 33, which are now, per that for loop, being added to the list. And then the logic is exactly the same. So way easier than it would have been in C to navigate or manage all of that stuff for me. There's another way to see this, syntactic sugar, if you will. If you don't like this syntax, whereby you are adding to the scores variable a new score by appending it using the built-in append function or method that comes with any list in Python, you can also do this. You can set scores equal to the existing scores list
Index
plus another mini list containing just that score. Or I can condense this a little further and say plus equals score. So it turns out plus is overloaded in Python in the sense that it's not a concatenation per se like for strings, but it's append. You can append more and more things to a list by concatenating two lists together in this way. So again, achieves the exact same thing, but maybe you prefer this syntax, if only because it's a little more concise. But in short, like lists are wonderfully useful in this way. OK, how about one other problem? When we implemented like a phone book back in week 3, let me go ahead and do this. In VS Code, let me clear my terminal and close out scores.py. And let me go ahead and create a new program called phonebook.py. And in this, let's write a program that just iterates over some names looking for one that I want. So maybe I have an array, a list called names. Set it equal to 3 of us, as in week 3. So Yulia and David and maybe John Harvard, like this, all 3 strings. Then let's go ahead and prompt the user for a specific name using Python's input function or our getString method function, prompting them for a specific name. And now let's do this old school with a for loop for each name in names. And I'm just keeping it short, n for names, n for each name. If the name I'm looking for equals the current name that I'm iterating over, then print out found, as we did weeks ago, and then break out of this loop because I'm done. And let's see what happens here. So Python of phonebook.py, let's search for my own name, DAVID, enter, and David's name is found. So that's kind of handy. Let's do this once more. Search for John. John is now found. Let's search for, say, another name, but let me mistype it maybe, like Yulia in all caps. I'm not handling any of the capitalization here, so I don't think she'll be found. And indeed, we see no mention of found. Now, this is a feature of Python that's kind of handy too. And it's a little weird, because in C and in Scratch, the only time you could use else was with conditionals. But we've seen in Python, you can also use else with exceptions, those special errors that can be triggered. You can even use else's in Python with for loops by saying else print not found. And what happens in Python is if Python realizes you never actually break out of this loop yourself, it will then print out this, only if you've not broken out. The logic being that, OK, you clearly didn't find who you were looking for, so else, let's just say as much. So if I now run this again, typing in Yulia's name, all capitalized, so miscapitalized here, enter, I do now see that she's not found. So it's just a nice little trick, because it's so common to iterate through things, fail to find a value, and then you just want to say some default, you want to execute some default line of code as well. But turns out, let's tighten this up too. Python does not need you to do all of this work by iterating over every name in the list, checking if each name is in there. Rather, we can tighten this up even more. Let me get rid of this entire for loop and just say this. If the name you're looking for is in the list of names, then print found, else, in this conditional, print not found. In other words, I can literally just ask Python, you search over the darn list for me, and if it's in there, wherever it is, return true in that Boolean expression, in that if conditional, the Boolean expression, in effect, so I can print out found or not found. So this too will just work. Let me go ahead and run this again at the bottom. Python of phonebook.py, search for myself, David, and I'm indeed found. But I don't need to implement the searching for it left to right. It's still using linear search under the hood, but someone else has now written that code for me, built into the language itself. All right. So what more do we get? So it turns out that in the world of programming, like maybe one of the most useful data structures is indeed a hash table, which gave us the abstract data type last time, known as a dictionary, which is just a set of key value pairs. What's wonderful about Python, unlike pset5 and C, is that you actually get a data type called dict, for short for dictionary, which gives you exactly that, key value pairs, but you don't have to implement any of the darn logic of problem set 5. It still gives you, in effect, something that looks a little something like this in memory, key value, key value, key value. But you don't have to worry about the array. You don't have to worry about the chains of linked lists. You don't have to worry about the hash function even. Python takes care of all of that for you. Now, this will be a bit of a mouthful to set up, but let me go ahead and do this. Back in VS Code, I'm going to go ahead and create another version of phonebook.py here by first creating a dictionary of people instead of just a list. Because up until now, we've had no phone numbers involved. I do actually want to have a bunch of names and phone numbers. And the way I'm going to do this is as follows. At the top of this file, I'm going to go ahead and create a list called people. I'm going to create a list called people. And a list, of course, uses square brackets. But every person now, I want to have some keys and values, like a name and a number. So how can I do this? Well, I'm going to make some room for this. This is not incorrect. I'm moving this close square bracket to a new line because I want every element of this list to be very clearly a dictionary, a set of key value pairs. And you couldn't do this in C, but you can do this in Python. In Python, you can use curly braces to represent a dictionary of key value pairs. How do you define the keys? You put the first key in quotes. You then put a colon. And then you specify the value for that key. If you want another one, you do a comma. You then do quotes. And you do another key, colon, and then its value. And if I think back to week 3 rather, we used +1, 6, 7, 495, 1000 for Yulia's number then. And that's it. It's a little cryptic because it's all on just one line, but it's like having 2 rows in this visualization here. Name, Yulia, number, +1, 617, 495, 1000 in their chart. So if I want a second one of these, I'm going to put a comma at the end of Yulia's dictionary. I'm going to put myself on the second line. So open curly brace, quote unquote, name, colon, and then David in quotes. Then comma, number, close quote, colon, +1, 617, 495, 1000 as well. And then lastly, a second comma, so that we'll put John Harvard in here. So his name is quote unquote John. His number is +1 949 468 2750. And now we have a list of 3 dictionaries. Each of those dictionaries has 2 keys and 2 values respectively. Syntactically, this is a pain in the neck, and we would probably just store all of this information in a CSV or a database or something like that. But for now, I typed it all up manually so we have a working example. Now, let's actually search this list of dictionaries for the people I want. Let's set a variable called name equal to the return value of input, prompting as before the name we care about. Then let's do this. For each person in that list of people, let's check if the current person's name equals the name the user typed in, then get their number by looking at that person's number field, and then go ahead and print out with an F string something like found, and then I'll just print out that number in curly braces. And then I will break out of all this, or as before, else let's go ahead and print out not found. So this is a mouthful, but let's consider what's happening here. First, on line 8, I'm iterating over every person in people. What is people? It is a list of 3 dictionaries. So on the first iteration, person is this person. Second iteration, this person. Third iteration, this person. And Python just takes care of that for me, like we've seen with our for loops already. If that person's name field has this name, then I found the person I'm looking for. Get their number, stored in a variable called number, if only so that I can print it out with this F string. Else, go ahead and print out not found if I never actually break out having found someone. Notice then that just like in C, when we use square brackets to index into an array, in Python you can index into a dictionary by literally using the same square bracket notation. So instead of saying bracket 0, bracket 1, bracket 2, you can say bracket name, quote unquote, and that will look up the value for that key. So again, it's like going into this chart that we see here visually, looking for name in the left column, finding that person's name, looking for the number value in the left column, and looking for its corresponding value at right. It's all sort of happening for us automatically. Now, it turns out we can do this more simply if we instead restructure our variable called people. So let me go ahead and do this. Let me go ahead and delete all of the code we just wrote, including that for loop, and let me redefine people as follows. And I'm going to leave the first version up there so we can see before and after. Let's redefine this variable as equaling people. But instead of people being a list of dictionaries, let's just make people one big dictionary whereby it has two columns, key and value, but where the key this time is going to be the person's name and the value is going to be their number. This is super useful in this case because I only have keys and values, names and numbers. This will not work if I also want to keep track of their email address, their student ID, and multiple values as well. In this case, it suffices to keep track of names and numbers, if only so that I can remove some of this redundancy of saying name, 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 number, number, number. Let's do it as follows. So people equals, open curly brace, close curly brace, and let's add a key of Yulia, whose number is exactly this one here. I'll copy paste to save time. Let's add another key whose name is David, whose value happens to be the same number. Let's add a third key whose value is John, and set that equal to this number, so that now at the end of these lines of code, we have Julia as a key, David as a key, John as a key, and their numbers respectively as values, effectively implementing this chart for everyone instead of one of these charts for each person. So if I go back to VS Code, let's get rid of the old, more verbose version. Let's go back here, and instead of using any kind of loop now, because there's no list involved, let's just do this. Prompt the user using the input function for the name whose number they want. Then let's just say, if the name you're looking for is in that people dictionary, well, great. Go ahead and print out a format string that says that person's number is whatever is in the people dictionary at that name's location. Else, let's go ahead and print out, for instance, not found. So the only weird thing here, I dare say, is this. If name and people works just like searching a list, but you can search a dictionary by key. And if you find a key like Yulia or David or John, it's going to allow you to use people as well, index into that chart at the name location with the appropriate row, and that's going to give us implicitly that person's number. Because even though we don't mention name, we don't mention number, this is what a dictionary is, a collection of key value pairs. And the key can be any string you want, and the value can be anything you want as well. So that was a lot. But you'll see then in the real world, these dictionaries, or really these hash tables underneath the hood, are so useful because you can constantly associate one thing with another. OK, a few final examples. I feel like it's a tough crowd because we're teaching an entire language in a week. But we're almost at the finish line here, and then everything else is going to be icing on the cake. How do we go about implementing now in Python some of the features we eventually introduced in C, namely things like command line arguments, which we've not used thus far in Python. I've gotten all of my input using getInt, getString, and Python's own input function, but I've never typed any words after the prompt when running Python and the name of a file. Well, how can I go about doing this in Python? Well, let me open up my terminal window here. Let's open up a program like greet.py, reminiscent of week 2's greet.c program. And let's do this. From a feature of Python called sys, import argv, which is very different from C, but the same idea at the end of the day. If the length of that argv variable happens to equal 2, let's go ahead and print out a format string that says hello, comma, argv bracket 1, close quote. Else, go ahead and print out the default from week 2, which was just hello, comma, world. All right, what has just happened? Well, first let's run it and try to infer. So Python of greet.py, enter. I didn't write any other words after the prompt, so I literally see the default hello, comma, world. What if, though, I write Python of greet.py and then David? Well, what's going to happen here is Python, via this sys library, is going to automatically put every word I typed at the prompt after the name Python into a list called argv by definition. I can then check how many words are in argv. And if it's 2, that means that the human typed in not only the name of the file to execute, but also something after that as well. So if I now run this by hitting enter, now I see hello, comma, David, because there's 2 things in that list, greet.py and David. There's no mention of Python because that's the interpreter. And without the interpreter, none of this would work anyway. You get the name of the file and the word you typed after that. It's not going to work, though, just like in week 2, if I do David Malin, because now argv's length will be 3 instead of 2. So I'm again going to get the default. But this is to say there is still argv. There's no argc because you can just use the length function, len, to find out what the length of argv now is. What more can we now do? Well, let me go ahead and propose that we introduce, how about exit statuses as well, whereby, recall that in C we had the ability to actually exit with some value, like 0 on success or 1 or anything else upon failure. Turns out that that feature is also tucked away inside of this sys library. Let me go ahead and create another program called, say, exit.py, just to demonstrate this one. Let me go ahead and import sys so as to have access not only to argv, but also a function in there called exit, which just worked in C. But in Python, we'll see that we want to use the version tucked away in sys. Let's do something like this. After importing sys, let's check if the length of argv does not equal 2 things. Let's go ahead and yell at the user, quote unquote, missing command line argument. And we didn't spend long on this in C, but we did something like this a few weeks back. And then let's go ahead and call exit of 1. Otherwise, if we get down here, let's go ahead and say, as always, a format string of hello, comma, sys.argv bracket 1, just as before, so as to greet the user. And then we'll say exit 0. But I do want to use argv that's inside of sys, and I want to use exit that's inside of sys, because according to the documentation, that's where these symbols are. So I can now do sys.argv, and I can do sys.exit and sys.exit, which just makes super clear that those 2 symbols, argv and exit, are inside of that sys library. And we did this earlier when I played around with the CS50 library, either importing specific things or the whole library itself. The idea here is ultimately the same. So let me run Python of exit.py with no command line argument. So enter, and I indeed get an error message. And this is probably not something you've needed to run since I last did it, but if you do $? After echo, you can quickly see what was the actual secret exit status. If I run this again with my actual name, David, enter, I actually get greeted. And if I do that $? Again after echo, I see now the secret exit status. So again, not something we've used often, but by convention, we can still do in Python what we've been doing in C, namely signaling that something was successful or a failure. Let's do one last set of examples that are reminiscent of past ones.
Come on, I'm done with this. Let's go. Wrap it up.
Recall that we've had this phone book that previously took input just from a hard-coded list of dictionaries or one dictionary. Let's actually reintroduce the idea of CSV files, comma-separated values, whereby we can actually save this information to disk so that we can add and add and add, and heck, even remove names and numbers eventually. In Python, one of the things that's wonderful is that you have built-in support for CSV files. You don't have to worry about the commas, the quotes, or anything like that as follows. So let me run code of phonebook.py to reopen that same file from earlier. But let's delete everything therein. And let me now do this. Let me import Python's own CSV library, which is, again, comma-separated values. And we used this briefly for my last phone book a few weeks back. Let's now open a file using the open function that comes with Python, it turns out, opening a file called phonebook.csv in append mode. So we can add to it as we done in the past, line by line. Let me then go ahead and ask the user for a name using input. And then let's ask the user for a number using input. And then let's actually put that name and number into the file. How can I do this in Python? And again, the goal here is not to absorb exactly how to do this in Python. It's certainly reasonable to look this up, but just to show you how relatively easy it is. I'm going to create a variable called writer, though I could call it anything I want. And I'm going to set that equal to the CSV library's writer function that just comes with it. And I'm going to pass to it the name of that file. This is a feature that says open this file and be ready to write to it hereafter. How do I do that? I can do writer.sh write_row, and I can pass in a list of the things I want to write to it. So I can say name, comma, number in square brackets. So that prints out a new line to the file. And then at the very end of this, let's do file.close to close the whole thing. Now let's see what just happened. Let me go ahead and open up phonebook.csv, enter, which is empty initially because nothing's in there. Let me show it at write continually. Let me now run Python of phonebook.py, enter, and let's do Yulia's name. Yulia, enter, and then her number, +1 617 495 1000. And watch what happens at top right when I hit enter, because that row will be written. All right, she's now in the file. Let me run it once more with my name, and +1 617 495 1000, enter. And now I am written to that file. And if I want to do this for John Harvard or anyone else, I can do that then as well. So what's nice is that notice that the write row function is actually outputting the commas for me. And if there were weird characters or commas, it would actually escape them by using quotes as well. As with Python in general, I can tighten this up further. In fact, it turns out that in Python, you don't need to be so pedantic as to open the file, then do some stuff, then close the file. There's this weird other preposition in Python, namely with, that allows you to do multiple things at once. So let me do this. Let me get rid of the close line. And let me instead do this. With open as file, colon, and then let me indent all of this here. That now is going to have the effect of actually doing all of that, but automatically closing the file for me. So I don't run the risk of forgetting, maybe leaking some memory somehow, and so forth. And there's one final flourish I can do here, too. Right now, I'm using this basic writer function, which essentially just writes a list, writes a list, writes a list. There's one other way where I can write dictionary after dictionary after dictionary, which is handy, especially if I don't just have names and numbers, but maybe email addresses and student ID numbers and other types of values as well. And I can do it as follows. Let me go ahead and let me say, oops, and actually, just to be clear, this code can be outside of that with, because I can ask for this once without the file actually being open yet. So let's change just these two lines here. I can create a writer, but this time use a dictionary writer, which allows me, again, to write dictionaries, key value pairs, instead of just lists of values, lists. I can say use this file for my dictionaries. Let's use field names of, quote unquote, name, comma, number. And then let's go ahead after that and do writer.write_row. And I can now pass in any dictionary I want that I want written to that file. So I can do name, colon, name. And then, for instance, number, colon, number. And let me go ahead and reopen phonebook.csv, enter. Let me move it at right here. Let me delete all of that. And notice what happens this time, more like your real world of using Excel and Google Sheets and Apple numbers. Notice now when I run Python of phonebook.py, enter, and I type in Yulia and +1 617 495 1000, enter. Notice that it too works as well. And if I wanted to as well using a dictionary writer, I could additionally tell this writer to include the names of these columns in that file so that when I open it up in Excel or Apple Numbers or Google Sheets, also the data is described in that first row of headers that you're probably familiar with from having just used spreadsheets in the real world. So long story short, this is not to ingrain in you exactly how you read and write CSVs or write in this case, but rather with just a few lines of code, like 6 lines of code, you can do a lot more in Python than you can in C.
4 more minutes, guys. 4 more minutes.
So now to end on a lighter note, let's do this. It turns out in Python, there's not only all of these libraries that come with the language, but there's also third-party ones that you can install as well. And there's a program you can run in a Linux environment, like your own code space, called pip, which allows you to install additional packages. That is to say, third-party libraries that other people have written. What this means is that in advance of your using cs50.dev, we essentially ran pip install cs50 to make sure that by default you just have access to cs50's own library. It does not come with Python, but it's out there in the cloud somewhere, and pip knows how to install it. But suppose I want to do something fun, like from a few weeks back where we did cow say, and we had a cow moo on the screen, and we had a dragon and other things too. Well, it turns out there's a package called cow say that I can install for Python with pip install cow say enter. You'll see on the screen a bunch of stuff happening because it's downloading it and it's installing it into the appropriate location. But now this means there is a library called cowsay in my own code space. So if I go ahead and create a program called like moo.py in this file, I can now import cow say, which will give me access to any functions and symbols therein. And I can do something like this per its documentation. Cow say library dot cow, because this is going to print a cow on the screen. And I can say this is CS50. And down here, I can do python of moo.py, enter. Oh, let's make the terminal window bigger. Let's do this again. Python of moo.py, enter. And I get a cow saying this is CS50 in a little speech bubble like that. I can make it more interesting now in code, though, as follows. If I shrink my terminal window and I use something like Python's input function, I can ask the user for their name, like what's your name, as we did way back with Scratch, and then C. And then I can use one of these F strings in here. And instead of saying this is CS50, I can say something like hello, comma, name in curly braces. Then down here, I'll make my terminal window bigger, run python of moo.py, enter. What's my name? David, enter. And now the cow is mooing dynamically based on what I've just actually typed in.
The cow is mewing?
We can do things even fancier
What?
than this. Lastly, let me see if I can type this out correctly. In my terminal window, let me go ahead and install pip install QR code, these two-dimensional barcodes nowadays that are seemingly everywhere. This is going to install a library that's going to know how to automatically create a 2D barcode for me based on any text that I give it, including a URL, because someone else wrote the code that figured out how to do all of that and output a two-dimensional code. So let me go into a program called qr.py that I myself will write, but I'm going to stand on that person's shoulders, and I'm going to import a Python OS library, which gives me access to the file system, so I can read and write files. And I'm going to import that person's library, QR code. I'm going to now create a variable called image, set it equal to qrcode.make, because I want to make a QR code. And I'm going to type in like the URL of one of CS50's lectures, so https://youtube/xvfzjo5pgg0. And hopefully, I made no typographical errors there. Then, on my next line, I'm going to call image, which is the name of that variable, .save. I'm going to save this as a file called qr.ping. Turns out this library supports different file formats, like ping, PNG for portable network graphics. So I'm going to say, give me that type of file. Then, I'm going to go ahead and run this program as follows. Python of qr.py, enter. No errors. I'm going to now open up qr.png, enter. Hide my terminal window, give you all a chance to open your phone and open the URL that's secretly embedded in this QR code. And at the risk of incurring your ire, there we go. This was CS50. We'll see you next time.
Oh, did he just rickroll them? Did David rickroll them?